Welcome to part 2, which is cumulative distribution function, or known as CDF. Still in discrete random variable, if x is a discrete random variable with probability distribution function px equal to x for x equal to x1 until xn, then the cumulative distribution function of x denoted by fx, capital of F, is given by fx equal to probability x less than or equal to x, or equal to summation of probability x summation of probability x equal to x, start from 0 until x. If we are given the fx, we can find the following probability by using the following concept of discrete random variable. Number 1, if we have probability x less than or equal to a, is actually equal to cumulative of a. Number 2, if you have probability x less than a, then it's actually equal to probability x less than or equal to a minus 1. And it also can be written as cumulative of a minus 1. It's easy to remember if you see over here. Up here we have probability x less than or equal to a minus 1. We have a minus 1. So we just straightforward take this a minus 1 and put it inside the cumulative. It's also the same with rule number 1. We have less than or equal to a, which is only a. So now you have your cumulative is cumulative for a. Okay, continue with rule number 3. Probability x greater than a, then you have 1 minus probability x less than or equal to a, where this probability is actually equal to number 1 over here. Probability x less than or equal to a is actually equal to fa. So you have 1 minus cumulative of a. Number 4, probability x greater than or equal to a is equal to 1 minus probability x less than or equal to a minus 1. So you will have 1 over here, 1 minus cumulative of, since this one, we just follow it, a minus 1, cumulative of a minus 1. Okay, then number 5, we have probability x equal to a, which is equal to probability x less than or equal to a minus probability x less than or equal to a minus 1, where this probability over here is actually f a, or cumulative of a. This is number 1, right? You can see over here it is actually number 1. And this one, probability x less than or equal to a minus 1, is actually number 2 over here, which is equal to f a minus 1. So you have to memorize or remember these 5 rules. Okay, then we have another, which is probability x greater than a less than b, which is also equal to probability x less than or equal to b minus 1 minus probability x less than or equal to a, where you will have this side is actually equal to probability b minus 1. Since it's follow here, as long as you have this sign less than or equal to, then you can just follow the right hand side over here. Straightforward, you get f b minus 1, and over here we minus f a, since we already have greater than less than or equal, so just straightforward take this a and it's become f a, cumulative of f a. Okay, then we have probability of x greater than or equal to a less than or equal to b, which is also equal to probability x less than b minus probability x less than or equal to a minus 1. And since this one is the sign is less than or equal, you straightforward take the B over here. So it's become FB, and minus probability of A minus 1. Why is it A minus 1? Because this is the less than or equal sign. So we straightforward take this one. Okay, continue. Number 8. Probability X greater than A less than or equal to B is also equal to probability X less than or equal to B minus probability X less than or equal to A. Since both have their equality sign, so we can just write it straightforward. Cumulative of B minus cumulative of A. Okay, then number 9, probability X greater than or equal to L less than B, which is also equal to probability X less than or equal to B minus 1 minus probability X less than or equal to A minus 1, which is also equal to which is also equal to cumulative of B minus 1 minus cumulative of A minus 1. So that's all the 9 rules or the 9 formulas for the cumulative distribution function, CDF or capital F. Let's say example 1, the probability distribution function of a discrete random variable x is given below. So this is the PDF or the probability. Okay. Then you will have when x equal to 1 and 6, the probability is 0.05. When x equal to 2 and 5, the probability is 0.2. When x equal to 3 and 4, the probability is 0.25, and you will get 0 for otherwise. Now you have to find from the PDF, you have to find the CDF, cumulative distribution function or capital F. So how are we going to find it? Okay, first, for x less than 1, we start with 1 over here. But for here, you write it down less than 1. Why? Because it's a cumulative. Cumulative means it's include the previous number. Okay, so fx equal to 0. And then why is it fx equal to 0? Because in here, we only have x equal to 1. For x less than 1, it is otherwise. So the probability will be 0. When the probability becomes 0, so do the cumulative distribution function or CDF also equal to 0. Next, we have x greater than or equal to 1 less than 2. We start with 1, include 1, and then less than 2 over here. So you have fx equal to probability of x equal to 1 plus probability x equal to 2. Why is it 3 not included? It's because here it's mentioned up. The x value must be greater than or equal to 2 and less than 3. So since it is a cumulative, we have to consider to sum up the number previously. So previously now we have 2. The previous number of 2 is 1. That's why we have to include the probability of x equal to 1 and plus with the probability of x equal to 2. So how do we get these values for the probabilities? We just refer back to this over here. Probability x equal to 1 is 0.05. When probability x equal to 2, we refer over here 0.2. So you get 0.25. Next, we continue from 3. Then we can include the 3. X greater than or equal to 3 less than 4. So the cumulative CDF for x is actually equal to numbers that are previously. Okay, so we have x equal to 1, x equal to 2, and x equal to 3. Only up to 3 because 4 is not included in here. So we refer back, x equal to 1 is 0.5, x equal to 2 is 0.2 over here, and x equal to 3 is 0.25. Then you sum up, you get 0.5. Again, we repeat the same procedure. If here we stop until 4, now we start again with 4, which is included 4. X greater than or equal to 4, less than 5. So cumulative of fx is actually equal to probability x equal to 1 dot 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 until x equal to 4. Up until 4. 5 is not included. So you sum up all the probabilities listed over here and you get 0.75. Okay. Next, x greater than or equal to 5, less than 6. The same procedure, you will need to sum up all the probabilities start with 1 until 5. Then you get 0.95. Then for the last one, we have x greater than or equal to 6. Why is it different with this sign over here? It's because 6 is the last number we have in our previous probability given. So it should be written in this form, x greater than or equal to 6. So which means that you have to sum up all the probabilities previously. Start from probability x equal to 1, probability x equal to 2, 3, 4, 5, and 6. So we know that for summation of discrete summation of probability for discrete random variable, it will end up with 1. The total will be 1. So now you have the cumulative distribution function fx given by this. This is the one we have found or we have obtained from all the calculation we done before. Okay, fx equal to 0. Fx equal to 0 when x less than 1, and then fx equal to 0.05 when x greater than or equal to 1, less than 2, and so on. And over here we have x greater than or equal to 6, x greater than or equal to 6, the fx is equal to 1. Okay, so previously we only have the probability of x less than or equal to x. Now you have cumulative distribution function. So this is what does it mean by obtaining the CDF from the PDF. Let's see example 2. The probability distribution function of a discrete random variable x is given in the table below. So this is the PDF. Find the cumulative distribution function fx. You need to find the CDF. We already have the PDF probability and we need to find the cumulative CDF. And then you need to sketch the graph for the CDF, the cumulative. Okay, solution. We know that cumulative of x is actually equal to probability of x less than or equal to x, and also equal to summation of probability x equal to x from 0 until x. Okay, the cumulative distribution function is the probability of x less than or equal to x. In other words, the summation of the probabilities of all x. Okay, what does it mean by here is that for the cumulative distribution function CDF, you need to start with the previous number. Let's say you have to find cumulative of f1. So you need to start from 0. Okay. This is the probability distribution table given. So we will start with x less than 0. So we don't have any x less than 0 over here. So directly we will have the cumulative equal to 0. And then we will start with 0, x greater than or equal to 0, less than 1. This one. So the probability will be 1 probability of x equal to 0, 1 over 8. Then we continue x greater than or equal to 1 less than 2. X greater than or equal to 1 means probability of x equal to 0 plus probability x equal to 1. So you have 1 over 8 plus 3 over 8, which is equal to 4 over 8 over here. It's actually the process of obtaining the cumulative distribution function is actually quite similar with how do you find your cumulative frequency in the first chapter, statistics. Remember, when you need to find cumulative frequency, you total up the previous values. Okay, then we have x less than or equal to 2 less than 3. So you will have to sum up 0, 1, and 2. Okay, so you have 0, 1, and 2. You have 4 over 8 over here plus 3 over 8. Then you get 7 over 8. Then for the last one, we have x greater than or equal to 3. Only the last number, the last value, you need to write it down in this form. X greater than or equal to 3, which is, we total up the previous numbers, which is 0, 1, 2. This is the one, 7 over 8, plus the current number, which is 3, 1 over 8. So you have 1. Okay. It must be 1. Otherwise, your answer is wrong. Because we know that the total sum of discrete random variable, you will have 1. So now you have the cumulative distribution table. So this is the table. We have to list down our x first, which is start from 0, 1, 2, and 3. And this is our CDF, our fx. Cumulative distribution table ataupun cumulative distribution function, CDF. Okay, fx over here, for 0 you have 1 over 8, and for 1 you get 4 over 8. Then for 2 you get 7 over 8, and for 3 you get 1. That's it. Okay, it also can be written as this. You have two options. Whether you want to write it down in table form, this one we can call it as cumulative distribution table, or you can write it down as this cumulative distribution function. It's the same actually. This is 0 for x less than 0, but we didn't include it in the table. And for x greater than or equal to 0 less than 1, it's actually this part. And so on until we end up with x greater than or equal to 3, which is equal to 1 over here. It's just that in this form you need to add one extra function or one extra interval over here, x less than 0, which is equal to 0. Okay, now you have to sketch the graph for cumulative of f. Since we already have this one or the previous table, you can use both. You can use either. Okay, let's start with x less than 0, which is equal to 0. So your y-axis will be your cumulative fx. Your x-axis will be your x values. So we have 0, 1, 2, 3, 4, 5. up until 3 actually, 0, 1, 2, 3, 0, 1, 2, and 3. Okay, so we start with this first. X less than 0 equal to 0. X less than 0 means it's on your left hand side. So it's actually equal to 0. Then we have for x greater than 0 less than 1. X greater than 0 but less than 1. So we have close bracket, or we call it as closed dot over here, and this one is open. So this is fully shaded and this is not fully shaded. Fully shaded means equal or included. So you have 1 over 8. Then we have x greater than or equal to 1 less than 2. X greater than 1, this is 1, greater than 1 but less than 2. So since it's include 1, this is fully shaded and this is not, because it's not include 2, which is the value for fx is 4 over 8. And then we continue with x greater than or equal to 2 less than 3. This is 2. This is 2. Greater than 2 means you draw it to the right until 3, but it's not include 3. So the value is 7 over 8. And the last one will be x greater than or equal to 3. This is 3. So it starts from here, equal to 1. It says here greater than or equal to 3. So you just draw a straight line over here without ending. That's all for your cumulative distribution graph. This is example 3. The cumulative distribution function fx of a discrete random variable x is shown as below. So this is the CDF with the x given here. Now you have to find A, what is the probability x less than 4, greater than or less than 6, B, C, D, E, and F. So let's solve one. Given this CDF, the first one is find the probability of x greater than 4, less than or equal to 6. So remember the 9 rules we have learned previously. So we can write it down in this way. So probability x greater than 4 less than or equal to 6 is actually equal to probability x less than or equal to 6 minus probability x less than or equal to 4. So this probability is actually equal, since it's half. So you can see over here, this is the less than or equal. So automatically we have f6. And this is also less than or equal. So we have 4 minus f4. So f6 minus f4. What is your f6 over here? You have to refer. f6 is here. f6 is 0.7. And f4 is within this range. f4 is within this range. X greater than or equal to 3, less than 6. So your x equal to 4 is actually within this range, which brings you the cumulative 0.3. So 0.7 minus 0.3, you get 0.4. Done with that. For B, find the probability x greater than or equal to 4, less than or equal to 6. So this is quite similar with this one. The only difference is the sign over here. The sign over here, you can see that this is less than, but this is less than or equal. The rest is the same. So we have probability x less than or equal to 6 minus probability x less than or equal to 3. Instead of write it down x less than or equal to 4, it should be x less than or equal to 3. So that is the difference between question A and question B. Okay, for this one we have less than, so we straightforward take less than or equal to 4, but this one it's include 4. means that you have to take the previous number since it is cumulative. So it's set with x less than or equal to 3. So to get again, this is actually probability x less than or equal to 6 is actually cumulative of 6, and this is actually cumulative of 3. So you have this value over here, f6 over here is 0.7, and then f3 is here 0.3. So you get 0.4. Now we need to find probability x greater than or equal to 3 less than 8. It is actually equal to probability x equal to or less than 7, because this does not include 8. So we start with 7 minus probability x less than or equal to 2. Remember to have one number slightly backward from this. So since here is stated 3, you have to take 2. So here become F7 and this one become F2. F7, if you refer to the CDF over here, it is actually in this range, which is 0.7. And how about F2? F2 is in here, which is 0. So 0.7 minus 0, you get 0.7. And D, probability x greater than 5, which is actually equal to 1 minus probability x less than or equal to 5. 1 minus this one is actually F5. So F5 is in here, in this range, which is equal to 0.3. So 1 minus 0.3, you get 0.7. E, find the probability of x greater than 3 less than 6, which is equal to probability x less than or equal to 5. Why 5? Because here it does not include 6, so we start with 5, minus probability of x less than or equal to 3. So we have probability cumulative of 5, and here is cumulative of 3. Cumulative of 5 is in this range, which is 0.3, and cumulative of 3 also in this range, which is 0.3. So 0.3 minus 0.3, you get 0. And F, probability x greater than or equal to 7, which is equal to 1 minus probability x less than or equal to 6. So 1 minus this is equal to cumulative of 6. So cumulative of 6 is within this range, which is equal to 0.7. So you get 1 minus 0.7 is 0.3. That's all. And this is our example 4. The cumulative distribution function fx of a discrete random variable x is shown as below. So the CDF this time is given in the table form instead of the piecewise function. So this one is given in table form. So you need to find probability x equal to 3, probability x greater than 2, probability x less than or equal to 2, less than or equal to 4, and fx, small letter of fx mean the PDF. You need to find the probability distribution function, or the PDF. First, you need to find probability x equal to 3 given this CDF table. So F3, cumulative of 3 is actually equal to probability of x less than or equal to 3, which means that you have to sum up probability of x equal to 1, probability x equal to 2, up until probability x equal to 3. Where you straight away get the answer in here, because this is the cumulative of 3, so it is actually 0.67. And then for F2, F2 means the probability of x less than or equal to 2, which is actually equal to probability x equal to 1 plus probability of x equal to 2, which is also you get it straight away from this cumulative. And probability x equal to 3. So probability x equal to 3 means that F3 minus F2, where you already get the answer F3 is 0.67 and F2 is 0.32. So the answer is 0.35. For B, you need to find probability x greater than 2. For x greater than 2, it means that 1 minus probability x less than or equal to 2. And here is actually equal to F2, cumulative of 2. If we refer back to the previous table, cumulative of F2 is actually 0.32. So you get 0.68 over here. And C, probability x greater than or equal to 2, less than or equal to 4, is the same with this. Probability x less than or equal to 4 minus probability x less than or equal to 1. This is actually straight away F4 and this is F1. Then you refer back to the previous table, you will get the answer for each of these cumulative. So the answer is 0.7. Next, we need to find the fx. Small letter of f means the probability distribution function or the PDF. First, we have to find the probability of x equal to 1, where it is actually equal to f1. So f1, from the previous table, you get 0.2. And then probability x equal to 2 is f2 minus f1. So the f2 minus f1, also from the table, just take it 0.32 and minus 0.2. And then you get 0.12. And so on. Okay, until you get this form. Fx of the PDF probability distribution function, or this one, probability x equal to x, is actually equal to, when x equal to 1, you have the probability is 0.2. So this is it. And when x equal to 2, you get the probability 0.12. So this is it. And when x equal to 3, it is 0.35, and so on. Don't forget to put 0 over here for otherwise. Okay, can you remember the CDF form of this? For PDF or the small letter of f, we add another extra, which is 0 for otherwise at the last row. But for the CDF, you add 0 on the top over here. So that's the difference between PDF and CDF. This is PDF. Okay, example 5. The cumulative distribution function of a discrete random variable x is given in table below. So this is the CDF given in table form. Find the probability distribution function of x. So you need to find small letter of f, or the PDF. This one. Solution. From the given CDF here, the values of probability x equal to x for x start from 1 until 5 are calculated by using this. The first one, probability x equal to a, is actually equal to cumulative a minus cumulative a minus 1. So this is actually from the 9 rules we learned previously. For probability x equal to 1, f1 minus f0. Why f0? Because it's a minus 1. So 1, the previous number, you minus 1, you get 0. So f1 is 0.05 and f0 is nowhere in here. So it's 0. So you get 0.05. That is for probability of x equal to 1. How about probability x equal to 2? So we have f2, cumulative of 2 minus cumulative of 1. So 0.3 minus 0.5. All the values are stated in here in the table. And for P3, for the probability of x equal to 3 is equal to F3 minus F2. Also, you get all the values from here. And for P4, probability of x equal to 4, you have F4 minus F3. F4 is 0.75 minus 0.6, you get 0.15. And then for the probability x equal to 5, F5 minus F4, where 1 minus 0.75, you get 0.25. So now we have obtained all the probabilities for the x value from 1 until 5. Now we can write it in the table form like this. The first row is x values 1, 2, 3 until 5, and the second row will be your probabilities of the x values that we counted just now. This one is the one we obtained. Notice that summation of probability x equal to x must be equal to 1. So if you sum this 0.05, 0.25, 0.3 and up until 0.25, you will get 1. Or instead of using this form or write it down in table form, you can write it down using this form. Fx equal to probability x equal to x equal to this. So you have two options, whether to write it in this form or you want to write it in table form. It's up to you. So this is how we obtain fx from capital Fx. F, small letter of f, means PDF or the probability distribution function. And capital letter of F is the CDF or the cumulative distribution function. Example 6. The cumulative distribution function fx of a discrete random variable x is shown as below. So this is the CDF. Given probability x greater than 4, less than or equal to 8, equal to 3 over 5. Now you need to find the probability distribution function of x. So we are given CDF. Now we have to find the PDF. Solution. We have x equal to 1, 3, 5, 7 and 9. How do we obtain this? From here we have 1, 3, 5, 7 and 9. So the first one, you need to find the probability of x equal to 1. Probability x equal to 1 equal to f1 minus f0. So how do I get this? This is actually from the 9 rules. So from the probability you get the cumulative f1 minus f0. So f1 is here a, f0 is here 0. So you get a minus 0, you get a. Probability x equal to 3 is f3 minus f2. So f3 is somewhere here, 3a. f2 is somewhere here, which is a. So you just minus it, 3a minus a, you get 2a. Probability x equal to 5. X equal to 5 here is 8a. And minus f4. f4 is here. 8a minus 3a, you get 5a. And then probability x equal to 7 equal to f7 minus f6. Where is f7? Here, 12a. And f6 is somewhere in here, which is 8a. So just minus 12a minus 8a, you get 4a. And the last one is probability x equal to 9, which is f9 minus f8. f9 is 1 minus f8 is 12a. So you get this. After we obtain the probability distribution function for x for all these values, we are given second hint, which is probability x greater than 4, less than or equal to 8, equal to 3 over 5. So this can be written in this form. Cumulative of 8 minus cumulative of 4. Cumulative of 8 is somewhere around here, 12a. Minus cumulative of 4 is here, which is 3a. So 12 minus 3, you get 9a. So 9a is actually equal to 3 over 5. And we get a equal to 1 over 15. So since we already know and we already obtained our a, you can substitute this a into these values to get the real numbers or to get the real values. So when we substitute a into this, you will get this form. This is in written in table form. This is in function. Okay. So the first row is the x value 1, 3, 5, 7, and 9. 1, 3, 5, 7, and 9. And the second row is your probabilities value. The probabilities for x equal to 1, 1 over 15. How do I get 1 over 15? Here, a. And a here is equal to 1 over 15. And probability x equal to 3 equal to 2a. 2a means 2 times 1 over 15. So you get 2 over 15 and so on until you get the probability x equal to 9. Now let's move on to median. I believe that we have learned median in the first chapter, which is the data descriptive. Now let's see what does it mean by median in this discrete random variable. There is one value that is particularly important in the cumulative distribution function. As learned in the earlier chapter, the median was defined as the middle value, with exactly half the data lying below that value and half lying above the value. So the definition is quite similar with the one we learned before. In the context of a probability density function, or the PDF, the median will be that point below which the area is 0.5 and above which the area is also 0.5. In other words, the median divides the area under the curve into half. This is how we determine the median for discrete random variables. If the median is m, then summation of probability x equal to m must be equal to 0.5. Remember just now we learned that summation of probability x equal to x must be equal to 1. That is summation for the whole values of x. But now summation for, if we want to find median, the summation must be equal to 0.5, half of the total probabilities. That is the median. Example 1. X is a discrete random variable with probability distribution table given this. So now we need to find the median. Solution. We simply take any two values from the x here. First one is probability x less than or equal to 2. Remember that this sign less than or equal means the cumulative. So we cannot simply just take the answer as 0.2. No, that's wrong. You have to sum up the previous values, which is 0.1 plus 0.2. Then you get 0.3 over here. This less than or equal sign is a cumulative. So remember to add the previous value. This 0.3 value over here is less than 0.5. And we take another value which is probability x less than or equal to 3. So similar with the previous one, probability x less than or equal to 3, you have to sum up 0.1 plus 0.2 plus 0.3. Then you get 0.6. Now this 0.6 over here is greater than 0.5, which satisfy the definition just now, which which state that one of the value must be below the 0.5 and one must be above the 0.5. So we can conclude that median of x is equal to 3. Example 2, cumulative distribution fx for a discrete random variable x is given by the following table. So this is the CDF in table form. You need to find A, probability x less than or equal to 1, B, C, D, E, and finally you need to find the median. Let's solve one by one. For A, from this table, probability x less than or equal to 1, less than or equal to 1, these signs, remember, this is the cumulative sign, which means cumulative of 1. So cumulative of 1 is here. This one you can straightforward take it as 0.68 because this is the cumulative. If this over here is not a cumulative but a probability, then you need to sum up each of these up until this. But since this one is already stated as a cumulative, then we just need to take this value straightforward. Okay, that's is A. B, find the probability x greater than 0 less than or equal to 2, where it is equal to f2 minus f0. f2, we can straight away take this value, f2 minus f0. So f2 over here is 0.79, f0 is 0.54, then you get 0.25. C, probability x greater than 1, which is equal to 1 minus probability x less than or equal to 1. This one over here is the cumulative of 1. So find the cumulative of 1 over here is 0.68, then 1 minus 0.68, you get 0.32. And D, probability x equal to 0 is actually equal to probability x less than or equal to 0 minus probability x less than or equal to negative 1. So this one become f0, this one become f negative 1. Why is it like that? Because this is the, remember, the less than or equal sign. So we can take it straightforward, less than or equal sign. So f0 is 0.54, this 0, 1. F negative 1 is 0.35. So you get this answer. And E, probability x less than or equal to 0 is actually equal to f0. So f0 is 0.54, which is greater than 0.5. Okay, question E actually need you to find median. So we take any value over here to make sure it's greater than 0.5 and less than 0.5. Then the second one is probability x less than 0. But does not include 0. Less than 0 means x less than or equal to negative 1, which is cumulative of f negative 1. Cumulative of f negative 1 is 0.35. So this value is less than 0.5. One of the value is less than 0.5 and one of the value is greater than 0.5. So we can conclude that the median is 0 or x equal to 0. Beside median, we also have mode for discrete random variable. Remember what is mode? Mode is the highest frequencies of the data. That is what we learned previously. So it's quite similar applied in here, the one with the highest or the repeated values. The probability distribution function for a discrete random variable x is given by this. This is the PDF. For x values start with 0, 1, 2, 3 up until 6. With k is a constant. This is k. Show that k equal to 1 over 17. Hence, find this, and lastly find the mode. Solution. This is the given PDF. With the unknown k, we still don't know what the value of k, but we know that for discrete random variable, for sure, the summation of the whole probabilities must be equal to 1. So let's sum up each of these values of the probabilities. So we start with k. We factorize the k. Okay, let's put the k outside. K 0 square. We start with 0. You substitute 0 into your x over here. So you get k times 0 square plus 1 square plus 2 square plus 3 square. Enough until 3. And then plus k. Why do we plus with k? Because for x equal to 4, 5, and 6, the probabilities are equal to k. So we need to plus k, plus k, plus k. Then this whole probabilities must be equal to 1. So after we solve for this part, we get 17k. 17k equal to 1, which means that k equal to 1 over 17. So this is shown. We are asked to show the k must be equal to 1 over 17, which is done. Now we need to find the probability x greater than 0, less than or equal to 3, which is also equal to probability x greater than or equal to 1 less than 3. Since here x must be greater than 0, x must be greater than 0, which means we will start with 1. So let's list down all the probabilities. The first one will be probability x equal to 1 plus probability x equal to 2 plus probability x equal to 3. Enough until 3. Since it's here, it's set at only 3. So 1 over 17, we know that our k is 1 over 17. So 1 over 17 times x here, 1 square plus 2 square plus 3 square. We only use this one because the value is 1, 2, and 3. So you get 14 over 17. Then second one, we have probability of modulus x minus 2 less than 1. So this one, when we open the modulus sign, you will get x probability x minus 2 greater than negative 1 and less than 1. Because the modulus sign, you will get the answer one is negative, the other one is positive. So now we want to make the x a single x in the middle. So the negative 2, you will need to bring it outside, to the left and to the right. So we have probability x negative 1. This negative 2, you bring it this way, you get plus 2. And then you bring it this way, you get plus 2. Now you have a new probability, which is probability x greater than 1 less than 3. So the value of x is in the middle of 1 and 3, which is also equal to probability x equal to 2. So probability x equal to 2, we refer to this, kx squared. But we already knew that k is equal to 1 over 17 just now. Our k is 1 over 17. So we substitute 1 over 17 times 2 square. Then you get 4 over 17. C. Probability of x equal to even. So even mean we only have probability x equal to 2 plus probability x equal to 4 plus probability x equal to 6. So we just add on 4 over 17. Refer back to the previous probabilities with the k just now. We just substitute the k with the 1 over 17 and we get these values. So now we have a complete probability distribution table. This is the probability distribution table. And lastly, you need to find the mode. Mode is a maximum value. So x equal to 3 is a mode for x because probability x equal to 3 is equal to 9 over 17, which is the highest value for probability. If we see over here, the highest will be 9 over 17. it is repeated 9 times over 17. So we can say this is the highest. So that's all about part 2, which is cumulative distribution function, CDF. And we also learn how to find the median of the discrete random variable and the mode of the discrete random variable. So let's take a break before we start with the last part of discrete random variable.